Next up, we have the Thomas Reed. When I started doing Mac malware analysis, reverse engineering, his name kept popping up. He ran a website designed, I believe, Adware Medic, which was an incredible utility to help detect and prevent adware on macOS, which is actually one of the biggest threats facing Macs today. It was so successful that Malwarebyte acquired his company, so Thomas is kind of living the dream. We're super stoked to have him give a presentation today. So without further ado, let's give a round of applause for Thomas Reed.
Thank you. Hey, first sticker.
Oh, what? Okay, Thomas also put the Objective by the Sea sticker on his laptop, which means he will definitely be invited back as a speaker for the next one. So take note.
Is this that? Yeah, that was the first sticker that was worthy.
Wow.
I didn't
think I could say that, Thomas.
All right, let's see. Let me switch the display. There we go. All right. So today we're going to talk about a code signing flaw in macOS. This isn't really something that's brand new, breaking news, but it's been around since the very start of code signing on macOS. But it's something that I've found over the last few years a lot of people are completely unaware of. So some of you guys might already be aware. I suspect that some people in the room probably are. I suspect others are probably not. So just to start, Patrick already introduced me, but I am Director of Mac and Mobile at Malwarebytes, and I do a lot of the Mac threat research there. So that's who I am. You can follow me on Twitter there if you're interested. So to start out, there's a lot about, there not being any viruses on the Mac. And in a certain sense, that's kind of true right now. By the strictest definition of the word, a virus is something that has to inject itself into another application, another program, in order to spread itself. And there's really nothing like that on the Mac right now. There has been in the past, but not really right now. There have been cases where malware has been added to an application. So a lot of you guys have probably heard of things like the transmission hacks, where KeyRanger was distributed through a hacked copy of transmission. Then later Keynap was distributed the same way. Proton hacked things like Handbrake and a number of other apps. But these are not being done in any kind of an automated fashion by the malware. This is something where the hacker gains access to a system, gets hold of some way that they can change the app manually and then upload it. So this isn't a virus. This is just somebody modifying the app. So the question is this kind of behavior actually impossible on macOS? And of course, I suspect all of you guys already know the answer. This is absolutely not impossible. And a big part of why this is not impossible is code signing and the way that code signing works on macOS. So let's take a look at how it works, just a sort of high-level overview, which is probably something you guys are all aware of. But so most apps, and this includes malware, it includes adware, all this bad stuff, most of it's signed today, because if it's not signed, It's kind of a non-starter. You know, on recent versions of macOS, you can't even tell it to allow unsigned apps. You have to kind of do a one-time exception that the average user doesn't know how to do. So if you're distributing malware, you either have to have some kind of a gatekeeper bypass or you have to have it signed. And one part of the whole process when you open an app is that gatekeeper will do a number of things, and one of those is it checks the signature on the app, makes sure that it's valid, that it hasn't been revoked, that the app hasn't been modified, breaking the signature. So you can be pretty sure when you first open an application that has been quarantined, if macOS doesn't object, it is validly signed by some certificate. You don't necessarily know if it's a valid certificate, like a legitimate certificate or not. So any apps that are code signed should be safe, right? I mean, that's the whole idea behind code signatures. Unfortunately, that is absolutely wrong. They are safe at a certain point, and only if the certificate is a legitimate certificate and they haven't been re-signed. So basically, an app gets quarantined when it's downloaded, gets some metadata added. That metadata tells macOS when the user opens this, kick in gatekeeper and do all of these checks. Look at it for malware, look at its code signature, et cetera. After the macOS allows the user to open the app, following that, user approval dialog, this is an application downloaded from the internet, that quarantine flag gets removed. So then you can open that app again without ever seeing that dialog. Unfortunately, that also means that you can open that app again for as long as it's on your machine, and it will never have its code signature checked again, ever. And that's the thing that a lot of people don't understand. A lot of people make the assumption, if an app is code signed, doesn't that mean that that code signature gets checked all the time? And it absolutely does not, unfortunately. So how can we misuse this? Well, malware generally wants a couple of things. First of all, it usually wants persistence on the system. Not always, but most of the time. So for example, with KeyRanger, first ransomware, it wasn't persistent on the system. When you launched the hacked transmission app, it would just load an executable, and that executable wasn't made persistent. So that kind of thing is an exception to the rule. Ransomware doesn't care if it's persistent. It just wants to get in there, do its damage, and then it's done. But most other malware wants persistence. The other thing that it wants is it wants to be hidden. So malware will try to be stealthy. A lot of times on macOS, it sucks at doing that. If you see things like com.apple in your launch agents, your user launch agents, you're like, no, that's not right. So, you see a lot of that with malware, and you just wonder, why aren't they trying to find a sneakier way of staying persistent? If I were writing malware, I could do a lot better than that. So you can actually achieve both of these goals by infecting apps that are no longer quarantined, that are already on the system. And the important thing to understand here is you infect an app that's already on the system, you're invalidating the code signature, but that doesn't matter because it's not getting checked anymore. And then every time you open that app, the malicious code gets executed. So you've got your persistence there. You don't need a launch agent or launch daemon because, like with transmission, every time you open the app, you're launching that malicious executable code. So the way that I did this for my proof of concept, and I'll say right up front, I sort of script kiddied this because I wanted to make the point that this is not hard, okay? So the way that I did it is I took a very simple little app that I made that I called Good. It's a very innocent little app. There's nothing wrong with it. So what I did, oops, there we go. What I did was I went inside the app bundle and I took the executable and I renamed it. I gave it a name 0 for no particular reason. It's just, some malware has used that name in the past when doing the same thing manually. So I figured, what the heck, I'll follow that pattern. So renamed it 0. And then I put in a malicious executable and named it Good. So at that point, you launch the app, it launches the malicious executable, and then that opens the original, which has been renamed 0. So user double clicks, the malicious code runs, and then that kicks off the actual legitimate code. So the user thinks that the application has opened, everything looks normal, but in actuality, malicious code is running on your system, and you don't know. Unless, of course, you look at Activity Monitor. That's one, you might see, hey, look, there are 2 copies of this Good app running, but the average user doesn't really look at Activity Monitor all that much. So, they're likely not to ever see this. And they're infected. So how hard is this? And like I said, I script kiddied this. Now, there are a lot of really cool, sophisticated ways to infect an app by modifying the binary and all this kind of stuff. That's too hard. We don't want to make this so hard. I mean, a script kiddie ought to be able to do this, right? So I intentionally tried to copy and paste as much as I could from Google searches, and I ended up with 22 lines of Swift code for the malicious executable. Now, of course, that's without any real malicious code in it, but still. And then 18 lines of AppleScript and 16 lines of shell script for a very, very script-kiddied installer. And that was it. So a little bit of Google searching, a little bit, I tried as much as I could to rely on Google searches, so it required very little actual knowledge, and it was done. There are some exceptions here. So I found out with my proof of concept that if I try to modify Apple's apps, they seem to have some kind of internal code signature detection, some sort of self-protection. And so any app of Apple's that I modified it like this, it would fail. It would crash when you launch it. Now, it's not, as you can see from this error message, it's not a particularly useful way of crashing, of alerting the user. The user just says, oh, well, this app crashed. I guess maybe I'll go to the App Store, go to the Genius Bar next week and see if Apple can fix this for me. Or maybe I'll just reinstall the app. Of course, the malicious code is already run, and who knows what else is done to your system. So the user has no idea that they might be compromised. And the important part here is, even though the app crashed, that's the legitimate code that crashed. The malicious code still ran first, and then it executed the legitimate code. So it doesn't matter that the app crashed, the malicious part still ran. Also, some third-party apps have their own self-protection. They do their own internal code signature checks. Pacifist is one example of this. Pacifist, if you're not familiar with it, it's a really nice program for cracking open PKG installers. You can look inside of them. And it does its own self-protection, self-checking. So if I modified that, I found that it would actually tell you that the application was damaged or might be infected with a virus. So that's a much more specific, better message to give to the user. They understand what's going on. Most likely it would just be that the app is damaged, but you still don't want them to just, not have the thought in their head that there might be an infection there. And there are some potential giveaways. One of those is that in my first proof of concept, I ended up with doubled dock icons. So what would happen is the malicious executable runs and you see the first icon pop up and start bouncing on the dock. And then the malicious code does whatever it does. In this case, pops open the calculator. So you can see the calculator icon came up next. And then finally, the legitimate code ran, and that application icon popped up a second time. And then the whole time the app's open, you got this other little icon just bouncing away like a kid on sugar. And you're like, why is it doing that? There's something wrong here. So that's a no-no. If you're malware, you don't want that. That's a giveaway. There was actually a really easy fix for that. So I ended up in my revising my proof of concept to fix that. You'd also, of course, see two processes in Activity Monitor, two processes in PS output in the terminal. And that's kind of suspicious, but at the same time, you could make it a lot less suspicious. So here you'd see a good process and then the zero process. I mean, we've as has been talked about here in like yesterday, in previous talks, that's suspicious. You see some single letter process, you don't want to see that. That's not normal. But what if I rename that to good helper? We've all seen these helper processes that are part of apps. Everybody knows about them. If I named it that, you'd just think, oh yeah, okay, so that app needs a helper process. And you wouldn't think any more of it. So, all right, so demo time. Let me exit this. I have a VM here with Mojave, because I wanted to point out that this does work in the latest system. And I've got this infector on my desktop. Simple little Apple script. Let's see. Why is the mouse not? Oh. There we go. All right, so I'll just run that infector. One interesting thing here in Mojave with this proof of concept is that it requires permission for Apple script, this script, to actually do what it needs to do. So if I were to do this again at this point, I wouldn't use the Apple script at all. I'd stick to shell script or maybe create a Swift app that would do the infection process, something like that wouldn't require this permission. And that's it. Now, in reality, if this were some kind of a malware infector, I would make it look like a document, maybe pop open a decoy document after it was done, something like that, something to lessen the user's suspicions. But, you can't tell that anything happened. So here I've got my good app already in the applications folder, and boom. Pops open the calculator, and no double dock icons or anything like that. If it didn't pop the calculator open, you wouldn't know anything bad happened. And this actually infected everything that's non-Apple in the applications folder. So if I open Google Chrome, boom, there's the calculator. If I open Firefox, boom, there's the calculator. So a very simple script and a very simple binary, malicious binary, and I've infected every program, every non-Apple program on the computer. All right, so back to the slides. So let's talk about how you can detect something like this. So first of all, you can always use the command line. You can use either SPCTL to assess the signature using this assess flag. You can also use code sign with the verify flag. Either one of those, they do the same thing and they actually give you the same output. So you can see here there's a legitimate copy of that good app on the top, and you can see that it verifies. And then on the bottom, there's the modified version of that app. And you can see that the code has no resources, but signature indicates they must be present. So there's something wrong with the signature there and it doesn't verify. So that's something you can check. You can also use OS query to do this. So you can use this particular select statement, and that will tell you whether or not an app is legitimately signed or not. So I gave it a path to the good, unmodified good app. You can see there's my legitimate Apple developer ID information. This is my personal one. So it's legitimately signed, right? Now, after modification, this is what you see. So it's no longer validly signed, it does not check out anymore, and you won't see my developer information anymore. Now, it's possible, this is probably a little far-fetched, but it is possible that the hacker could, on the fly, re-sign this with a certificate that's distributed within their app. That seems less likely to me because they'd have to expose their certificate to the outside world. But it's a malware certificate, so maybe they're okay with that. They know it's going to get revoked soon anyway. So if malware did do that, you would see different team ID, different identifier. So there you'd have to know what you were expecting to see there. So if you had an app from me and you looked at the signing information and it said something like this, you'd immediately know that's not correct. That something's fishy there. Also, another solution, and it was mentioned yesterday, is Google Santa, which it's really cool. It does binary whitelisting and blacklisting. You can run it in lockdown mode, where the only processes that are allowed to run are the ones that you've whitelisted. And if it's not on the whitelist, it doesn't get to run at all. And the nice thing about this is that Santa actually takes the code signature into account. So if you modify the app's signature, even if it's on the whitelist, it still doesn't get to run. So in this example, I modified that good app and Santa blocked it, even though it was on the whitelist. And you can see there that it says publisher not code signed. So that works pretty well. That's a really nice system for blocking stuff. There are some pros and cons here. So the big pro is that this is difficult to bypass. I'm not going to say it's impossible. I don't know of any bypasses, but I never say never. When it comes to computers, there's always a vulnerability in everything. So, but it is difficult to bypass. If you can't run the malicious code on the system at all, it's really hard to infect the system in the first place. You can't run this malicious infector if you can't run it. Now, on the other hand, there are some cons as well. If you're running this in some enterprise environment, you're going to end up getting a lot of people asking you, hey, can you whitelist this? Sales is going to say, hey, we just got this new app that we're demoing. Can we whitelist this? And then, your developers are going to say, hey, why is this blocking all of my dev tools that I want to run? So it will cause a lot of overhead with people wanting you to put things on the whitelist, having legitimate things blocked. And it's really unrealistic for certain kinds of users, particularly developers, because they're always running all kinds of weird stuff. A lot of it's self-built. So it's something that it may work for some of your users, but it probably won't work very well for all of your users. So, but with that, we're all set, right? I mean, we can use Santa or something like that, and we can detect that an application has been modified, and we can just block it, right? Just block any app that's been modified where the signature is invalid, right? Unfortunately, it's not quite that simple. There are a lot of things, of course, you guys all know there are a lot of things out there that have no signature at all. Things like a lot of open source projects, OpenVPN, for example. It's just not signed at all. And it's legitimate, so you've got that. But then worse, You've got applications that are installed with obsolete or broken signatures, or even apps that break their own signatures by modifying themselves at runtime. So that's a problem. If you're relying on code signatures to make sure all your apps are safe and apps are actually not signed or are breaking their own signatures, I mean, what do you do? So, for example, OpenVPN. This is a very popular VPN. I actually have this on my computer right now. It's the one that we use at Malwarebytes. And if you try and look at the code signature, it comes back, it's not signed. So the problem with that is, if I were to get access to a system with OpenVPN on it, I could modify OpenVPN and you would never know because there's no code signature. You couldn't tell that it had been modified unless you went and downloaded OpenVPN on another system, installed it, and then grabbed all the parts from here and grabbed all the parts from there and then compared them. Nobody's going to actually do that. So, so this is a problem. You can't verify that application. Other applications have obsolete signatures. And so I'm going to pick on a big one there from a company that likes to pick on other people about their own vulnerabilities. So Google Chrome, for whatever reason, this is the latest version of Google Chrome, has an obsolete signature. So it was built using older tools. It's not up to code, so to speak. That's a problem, and I've actually seen malware, it's more adware that will get inside and make changes inside the Chrome app. So this is actually happening to Chrome. Not commonly, but it does happen. Others are broken in other ways. So for example, I really like Yubico. I like the YubiKeys, but their YubiKey PIV Manager app is not quite right. So if you look, you can see it's validly signed. Well, it is signed. You can see the team identifier. You can see all that information. But if you try to verify that signature, you see that there is this PIV man package file inside of it that is not signed. So that's a problem. That means that you could replace that file with something malicious and you would never be able to tell because that's not signed. And probably the worst that I saw was the Zoom app. This one's bad. If you've ever looked at the Zoom installer, it is absolutely ridiculous. There's actually I should have put the link to it here, but there's actually a blog post out there that calls this as bad as malware. Because it really is the way the installer works. Like some of the stuff's getting installed by the pre-install script. The payload is practically non-existent. It kind of builds the app. It doesn't actually have the app in the payload and just install it. It actually builds the app through the scripts. So it's ridiculous. And if you try to validate the code signature on the Zoom app, you get all these errors. So that's bad. Now I reported this to the Zoom team, and to their credit, they responded very quickly and said they've identified the problem and are working on fixing it. So we'll see. Hopefully it'll be fixed because I use this app every day and I hate the fact that it's this janky. It's bad. So but that just raises the question. You've got all these broken signatures out there, all these non-existent signatures. What do we do about this? So there's not a good solution right now. It's just not a good situation right now. So What you really should do is every app that you use, you should always pay close attention to the signature. Now, I know not everybody is going to go and check code signature on every app every time they run it. That's kind of silly, but yeah, just check it every now and then and see. And of course, pay close attention to the apps that are messed up. You know, it's going to be hard to impossible to tell if they've been modified, though. If you find an app that has a broken or missing code signature, report it to the vendor, like I did with Zoom. You know, you may get a very positive result, hopefully. You may not. In some cases, like with open source projects, there are issues with code signing, so you may not be able to get an open source app code signed, but maybe you can. Maybe you can find a way to help them figure out how to do that. If any of you guys are developing apps, make sure you get the code signing right. Don't do any of these weird things like some of these folks have done. And I'm not really, other than the Zoom app, which was just, that was bad, I'm not necessarily trying to cut down any of these companies. Everybody makes mistakes. We actually shipped a version of Malwarebytes at one point that had a minor code signing issue in one of the components. So everybody makes the mistake. The important thing is that you make people aware of it so they can fix it. And then obviously we've got to spread the word on this, and that's what this is all about. This is not about me saying, oh, look at this new vulnerability that I found. This is all my work. You know, this is nothing new. This is not my discovery. All I did was play around with it to try to raise awareness of this problem. So please spread the word. If you know a developer, tell them about this. Also, we should encourage all developers, in my opinion, to implement their own code signing checks in their apps. It's not perfect, obviously. If I'm targeting a particular app, it doesn't matter if it has code signing checks. I can just go in there and change the binary and get rid of that check, right? But the kind of script kiddie thing like I did here would absolutely not work undetected. So that's doing your own code signing checks is important. I kind of doubt that Apple's ever going to implement a code signing check every single time an app runs, because I've been playing with this a lot lately, and it can be very time consuming. I actually tried to execute an OS query script on my machine. I did a select that looked at the code signing of everything in the applications folder. And then I just sort of sat back and waited, and the fans started spinning and were getting louder and louder like an airplane taking off. The machine got really hot. And half an hour later, I was starting to get a little bit worried that it was going to melt. So at that point, I terminated it. So that makes, that it is a problem. It takes a little bit of time to check these code signatures. So I doubt it's something that Apple will or can do for every single process on the whole machine. But still, if you're an app developer, check your own code signature. So. And that is it. If you want a copy of the slides, it's right there. I am not trying to trick any of you guys with this, like some people have done in the past. So the last time I gave a talk with something like this, the person that spoke right before me had a QR code just like this, and rickrolled everybody in the room. So. This is legit. I'm not rickrolling you. So, and that's it. Any questions?
Does app notarization in Mojave have an impact on this, or is it still not checked as?
The question was, does notarization in Mojave have any impact? And I have done a little bit of testing. I downloaded a couple of apps that are notarized, and I used my script on them, and it still worked. So notarization doesn't actually fix it. Yeah.
I would note that notarization means you can't re-sign with a developer ID. In the future,
Yeah, absolutely. I mentioned that I had seen adware that was changing Chrome. It was actually changing some data files that had some JavaScript in them. So those actually were not, because it was not actually code as you could see, as the system could see it, that wasn't part of the code signature, so it actually didn't invalidate the code signature. Yeah.
As a matter of efficiency, if you wanted to check the code signature every time you ran an app, couldn't you first check much more efficiently if the file has changed?
Absolutely, yeah. Yep, you could check. Now, I don't know, there might be some problems with that. I don't know, because it would be possible for malware to take note of the creation and modification dates and then reset them after it modified. But there might be some way that somebody smarter than me could figure out to get the actual modification date. So, yeah.
Why would malware want to work this way if the infector is already there?
That's a good question. So the question was, the infector is already there, so why would malware want to do this? And the main reason is that there's almost always a second stage to any dropper. So you run whatever this dropper is on your system, it almost always will drop the actual malicious payload somewhere on the system and give it persistence. So that may be through launchd, it may be through cron, it may be as a login item. There are a lot of different ways that it's done, but just having the dropper or the infector there doesn't actually give you persistence. Now, if it's ransomware, that's all you need. You just need it to run once and that's it. But any other kind of malware that wants persistence is going to need something. It's going to need to deploy something to the system. Yeah.
What's a common infection vector that you see? Like, how is this normally delivered?
I actually have not seen this in the wild yet, which is good. But it makes me nervous because this is really easily possible. So I'm really curious why we haven't seen it yet. But a lot of the common infection vectors these days for adware and stuff like that, it's always a fake Adobe Flash Player installer. When it's not, it's things like, crappy video plugins or video players or, pirated stuff, all kinds of stuff like that. And then, of course, with actual malware, it can be things like fake documents, so like an app that looks like a Word document. Or it could actually be a Word document with macros in it, although that's a little iffier because Microsoft has got recent versions of Office sandboxed. There are some ways to escape from the sandbox, so it's not a guarantee, but I've run some malware that had Mac-specific code in the VB scripts, and it didn't drop what it was supposed to on the system. So, yeah.
You use an embedded plist with LSUI elements to make it not show up in the doc, right?
Yes, that's exactly it. So he asked if I used LSUI element in the plist, in the info plist file in the application bundle. That's exactly how I hid that bouncing icon. So basically you set LSUI element in the info plist, and it says that application is a background task, basically. So it doesn't show up in the doc. And then as soon as it launches, it removes that from its own plist so that when it launches the legitimate code, that one appears in the doc. And then when it quits, it resets it. So every time it's able to hide the malicious process from the doc. Yeah. I did not, because I don't know how exactly. But if anybody has any contacts on the Chrome team that I could, If you know anybody, let me know, because I would love to be able to notify them. You what? Cool. Anybody? Oh, yeah. It probably would, but it depends depends on how they're doing it. If you're dropping a payload that they're already familiar with, then they ought to be able to detect it. I kind of don't think that a lot of them would be looking for this kind of behavior with behavioral detections, but if they did, they could catch it. So, anybody else? All right. Thank you.
Thanks again, Thomas. I don't know about all of you, but I'm super stoked he's one of the good guys.